So in the links tab, you're going to see links for the course. I'm going to record every lecture and put a link to that recording here in the links tab. I'm just going to call it date and hour. So like this will be called 8/19/2022, 7th hour, whatever, or something to that effect. I'll archive the old agendas and put them in the downloads. So if you're absent for like weeks at a time and you need to go back and look at what happened like 2 weeks ago or whatever, you can see that stuff there. Syllabus sign-in sheet are both there. We'll talk about what those things are for later. Feel good about the bulletin board page? It's all there is. There's no other topics or anything else to look at. It's all going to be just right here on this page. Cool? One thing to remind you, especially in the links one, is that show more, because it's going to get real long. Because you have one for every day of class. But just keep that in mind. All right, let's look at the syllabus. So in this class, I use OneNote to do all of my notes for you guys. We're going to do some homework stuff in OneNote. If you want to take your notes in OneNote, that's going to be okay. You should have the functioning stylus if that's the case. You don't feel obligated to do it that way. You don't have to. But if you'd like to do that, that's fine. Keeping in mind that you're not using your tablet to watch YouTube videos or set your fantasy line up or shop for prom dresses or whatever you might rather be doing than math class. The way the course is set up, so 50% of your grade comes from the test scores, 20% from homework quizzes. We'll talk about what that is in a second. 25% from the homework and 15% from the final exam. The same grades as the handbook. Extra help CT is the best time to catch me. Mornings are going to be tough. I had that in there, but my daughter's with me now that I'd have to drop off at the lower school. So it's like, I feel like I get here, we sit for 10 minutes and I have to leave and drop her off. And then I get back like 2 minutes before the bell rings. So CT is the best time to catch me. There's a regular course. So to get the fancy certificate at the awards convocation, you need to do 95% or better, both semesters. The homework. So I'm going to assign I'll give homework each class typically. That homework is part of the weekly problem set. The problem set isn't due until Sunday at midnight. So if we had class Monday, Wednesday, and Friday, the homework you got on Monday and Wednesday would be part of that Sunday's homework set. The Friday's homework would go into next Sunday's homework set kind of thing. Usually I try to make sure there's at least a class in between that due date and a homework being given so that you have a chance to ask questions and that kind of stuff to finish things up. That being said, please, please, please don't make it a habit to be like, okay, Sunday is math homework day. I do nothing in between. Not the best way to learn mathematics. The sprint, coast, sprint, coast, sprint, coast. Bad for mathematics in particular. Because what we do on Monday is the building for what we do on Wednesday, which is the building for what we do on Friday. And if you do nothing in between Monday to Sunday and find out like, oh, I don't understand anything that we were doing on Monday, that's a big problem for everything that happened on Wednesday and Friday too. Okay. So not that you need to complete everything every single day in between, but you should do something. Spend some time with the homework, like get an idea of what you know or what you don't know in between. You don't have to finish all of it if that's not what you're into, but you should be doing some homework in between classes, okay? In addition to the weekly homework assignments, we're going to have some daily things. These daily things are going to be done online. We'll talk about a little bit how that's going to work in a few minutes. And the first couple of rounds, as I figure out, it's the first time I'm going to be using this online platform to do these daily homeworks. We'll kind of figure that out together as to like what works and what doesn't, or what's fair and what's not fair, as to how I'm going to assess these and how we're going to be grading them and that kind of thing. Okay. All right. Late homework. So this is straight out of the handbook or whatever. This is the policy for late assignments. The way we're going to be collecting these weekly problem sets is we're going to turn them in with OneNote. If you've not done this kind of thing before, there's usually some hiccups along the way in terms of you guys understanding how to use OneNote and make sure that I can see everything that I'm supposed to be able to see from my end. So probably this 1 week deduction, I wouldn't count for probably the first month or so as we getting used to using this system and having things where we're supposed to have them and making sure things are synced the way they need to be synced for me to be able to see it and all that kind of stuff. So in the case that you see something marked missing or incomplete or whatever, that you're like, I had all of that stuff in my notebook, you send me, we'll resync and send me an email and we'll figure it out. Okay. But eventually that's gonna go away and we'll start marking things late. Okay. The homework quizzes. So the homework quizzes, I typically give at least one quiz per chapter. Most of the time it's exactly one, but sometimes if the chapter is big, it might be more. The homework quizzes are going to be unannounced, but usually I give you some good indication of like something's coming this week. Or if I were you, I'd want to make sure I've done up through section 7's homework, something to give you an idea that, it's coming. These homework quizzes are based on recent homework assignments. They're closed book, and they're graded on 10-point scale based on overall demonstration of understanding. So typically these homework quizzes are like 2, maybe 3 questions. They're meant to be quick, like 10, 15, 20 minutes tops. So it's not going to be one of these things like, oh, I got 2 out of 3 questions. That's a 6 or a 7. Like, it's not like that. It's like, oh, I got 1 wrong here. But the reason you got it wrong was because you like dropped a negative sign. To me, that's a 9 or a 10, right? Like you did A work really aside from making a transcription mistake. Like, oh, I got 1 wrong, and it's like I made some algebra mistake. It's not the stuff we were studying. I did that part right, but I made like an algebra mistake that would have been from a previous course. Like that's a 9, maybe an 8, depending on how the severity of that mistake. You kind of get the idea. Say you get them all wrong, but you had like kind of the right idea on all of them. Like you kind of started okay, and then it went off the rails or whatever. 6, 7, depending on what you did, for nothing correct. Right? So the idea here is I'm looking holistically at what you've done. We're not counting points. Really, I'm looking at the quality of the work that you've done and trying to say, okay, is this A, B, C, D work? As long as you're doing some stuff that's kind of right, it's hard to get much lower than a 6 or a 7. Okay? And I think that's probably the most fair way of doing something that's kind of unannounced, is to just kind of look holistically at it, especially if it's short, like it's supposed to be. Okay. Tests, there'll be one at the conclusion of each chapter. Partial credits awarded based on the merits of the work demonstrated. Since this is the regular class, you'll be given the option to use a half a sheet of notes on your tests. That's nice. To do that, they have to be turned in to me on the review day. So you'll have, by the end of that class, or even the end of the school day is often okay. But the notes are not allowed on makeups. So if you're absent that day of the test, you got more time, so you don't get the notes. Fair enough. Reasonable, I hope. If you're somebody that does the extended time, set that up through the counseling. The only thing that I ask is that you're doing the test or whatever in one setting. Dress code, you've probably heard that about 1.5 million times. Computer usage, again, as long as you're doing what you're supposed to be with your tablet, there's not a big deal. Academic honesty, that's just copied straight from the handbook. I have a weird page break in here where something I must have moved around and not noticed. If you're absent for a homework quiz, best time to do that is during CT. Just come by during CT and be like, hey, I'm here to make up this homework quiz that I missed, and I will let you do that. If you're absent on a test day, I just ask, or to make up the test, you're going to have to either do it in your study hall or in the testing room. All I'm going to ask is within 1 week of your absence that you've contacted me to let me know like how you're planning on making up the test. The test doesn't need to be made up in a week, but we need to have a plan. Like, a week from Friday in my study hall. Sounds good. Okay? If you miss just a regular class, you don't need to contact me for anything. You can watch the video. You can look at the notes that are going to be in OneNote. You can look at the agenda on My Notre Dame and kind of just follow along with what we've done, right? I try to make it pretty easy in that regard. At the end of the semester, I'm going to drop a low homework score. I'm going to drop a low quiz grade, and I'm going to give you the option to take a doubled high test score or retake a chapter test where the max new score is capped at 85%. I think that's now the policy department-wide. The plan for this course is we're going to try to do up through chapter 7. We'll see. Usually we can get through 6 or 7, somewhere in there. In the first semester is pretty reasonable for this group. Questions so far about the syllabus? Okay. The last page of the syllabus is a syllabus sign-in sheet just saying that, hey, I read this and sounds good to me, and I showed it to my parent, and they said, okay, I looked at this. This is going to be your first homework assignment to turn in. We're going to turn this in on OneNote. We'll talk about how to do that in a second. And the due date for that is Sunday at midnight. Okay? So we've said a couple of things about OneNote here. Let's get that set up. So I need you guys to take out your tablets, turn them on, and open up Microsoft Teams. If you're not sure where Microsoft Teams is, the easiest way to get to it, if you type or click on the magnifying glass and you just type in Teams to the search bar, it should pop right up for you. I'll give a second for everybody to kind of get that opened and going. When you get to Teams, in that far left navigation bar, just make sure you're on the Teams tab or Teams button there. You should see a bunch of, or at least one square with 7th hour trigonometry, if not more. If you've changed your schedule recently, we may have to add you. If you don't see it, let me know so I can add you. Okay? Because I think at least one person in here is added. Since I said this, it's and you're Emma Ciesla, right? Okay. I will get that right now. I just want to write your name down on this thing so I can update that other one. Anyways, all right. Add member. S or C. There we go. Anybody else needs to be added? So far, so good. Okay. Emma, if you resync that, or maybe you have to close it and open it again, but you should be there now. Yes, sir. You're missing 2, it seems. Okay. Yeah. And you're Matt Wagner? Yeah. Okay. I try to do this all in advance, but sometimes you make mistakes and you type in like your brother or sister's name and, you know, or you just miss the person when you're going through your list because you're going fast. And all right, how we doing? Has everybody got Teams open?
I can't get into Teams. Like it won't even. Mine won't either. I'm like downloading it like from like Chrome.
Interesting.
It says like I need like a password for the administrator.
Yeah.
Mine won't even like.
You should have Teams already on there, but
I have it, but it's just like not. Okay, I
let me think. There should be a way to run that as a web.
Our services aren't available right now.
Okay, so try this. If you go and you type in Teams to your search bar, and then you go over and pick the web option, try that.
I re-downloaded it. It's like.
Because if you okay, is it installed though? Because I don't know if they'll let you install something on your own. I think you're going to get prompted to supply like administrator's password.
No, it lets me download it, and then once I exit out of the app, then it gives me the thing again.
Yeah, so you're probably gonna need to run it through off the Microsoft website.
Okay.
So again, if you go to the search bar and you type in Teams and then you pick Web and do that, it should open Microsoft Teams through your web browser. So even if it's not downloaded on your computer anymore, you can still access it. Ava, did that work for you?
So I opened it in the browser and it says our services aren't available right now. And then it also won't open like the app.
That is super strange. Okay. Well, we're recording all of this. You're gonna have to make a trip to IT. Not a big deal. We'll get it sorted out. This is the only day you need to use Teams, but we'll get it sorted. Okay? You cool? Okay. If you think of something else to try, continue to try and let me know if you get it to go. Or if it decides like, oh yeah, now I want to work. Because sometimes, who knows, technology, right? All right. So we're mostly all into Teams, and we're at a screen that looks kind of like this, where you have 7th hour trig as one of the things you can see. Go ahead and click on that. You should get to a screen that looks pretty similar to this one. In that middle navigation pane, you're going to want to click Class Notebook. When you click on that, it's going to open up an image of Microsoft OneNote in that right-hand pane. It could take a minute to do this, particularly if I just had to add you. It's going to take a long time for that to show up. It's going to say, like, wait while we load your notebook or something. And when I say a long time, I mean like maybe like a half an hour, 40 minutes or something ridiculous. That's why I tried to do everything in advance. And obviously, if you change your schedule, I couldn't do that. Or sometimes you make a boo-boo and it just didn't work out. But everybody okay? Okay, so you're going to go and look at that pane that has the Microsoft OneNote in it. What you're going to look for is the drop down that says Open in Browser. You're going to click that drop down and select Open in Desktop App. You can ignore this little pop-up, and eventually Microsoft OneNote will open up on your computer automatically. It'll load in the notebook for you, and you'll be at a screen that looks something like this. It may take a minute to load in the notebook. Obviously, mine, everything is already loaded in, so it didn't take any time. It just popped up immediately. Yours could take a minute.
I can say I have one for Ken.
If anybody needs assistance at this point, let me know. I'll walk by and see what I can do to help you out. If you're just waiting, I get that. Some of us are stuck waiting. Some of us are stuck where Teams wouldn't cooperate for us. I don't know why. But anybody else not get their OneNote to open? Okay, so far so good. If you look at your Microsoft OneNote, at the top you should see 3 tabs. One says Collaboration Space. We're never going to use that for this class. The other tab says the Content Library. If you click on that, you can see that the Content Library, I've already put some stuff in there. You'll see the syllabus and the syllabus sign-in sheet are already in the Content Library. The Content Library is going to be the primary way that I share things with you. Like if I need to give you a worksheet, or if I need to give you the textbook pages, or I need to give you the homework assignment or whatever, this is the way where I'm going to share it with you. All of those things are still available. If you click on the textbook link on the page, which is everything is there, rather than just the stuff you need. So it's up to you. But OneNote, I try to make it really easy and have it all in one place where you don't have to open anything or download anything or remember where it's saved at. It's all going to just be sitting there right there staring at you in the face. Okay. The third tab is going to have your name on it. If you click on your name, you're going to see 3 tabs there, one for the archived homework. That's a place to store the homework that I've already graded if you'd like to. You don't have to store anything there. If you just want to delete it, that's fine. There's a tab for the current homework. That's the stuff that I would be grading next. So that's the homework that you've completed but hasn't been graded yet would go there. And then I have a page for notes and handouts. You don't need to put anything there, but if you like to take notes on OneNote, or you're putting my notes from OneNote in there to look at, it's just a space so you don't have to like toggle up, go to the content library, sort through that, toggle back through, go back to your homework page or whatever, trying to make things a little bit more convenient for you. Everybody okay with that? All right, so the syllabus sign-in sheet is going to be done or going to be turned in OneNote. So the first thing we're going to do here is we're going to move that sign-in sheet into your notebook so you can sign it and have your parents sign it. You could also print it out and like take a picture and drop that in also. We'll show you how to do that in a second. But it's probably just easiest to do it this way. So I'm going to go to the content library. On the right pane here, I'm going to right-click and just hit copy. And then I'm going to toggle up, go to my name, under current homework, and then in that same right navigation pane, I'm going to go ahead and hit paste. Everybody's cool? So far, so good? Now notice, Alexis, have you pasted that in there?
Yeah.
Okay, notice on my end, I don't see anything. Why not? Well, how do these shared notebooks work? It's not real time that they're being updated. The data from Alexis's computer has to go up to the cloud, and then my computer has to fetch it from the cloud back to my source. And now it's popped up, right? It took a minute, though, for Alexis has been done probably for a minute. It took a minute for that process to happen, right? Can that happen faster? Yes. So on your end, what you'd want to do before you close your OneNote notebook, particularly if you've made changes, is to make sure that your notebook is synced, that it's pushed all that data up to the cloud, so when I open my notebook, I can pull all that data back down. So you can force your notebook to do this sync. Okay, the easiest way to do that is where it says 7th hour trigonometry notebook, is if you right-click that and you select sync this notebook now. If you look over here where it has the picture of the notebook, you see the green circle there. That's telling you that the notebook is syncing. When that green circle is gone, it means the notebook is finished syncing, and it would be safe to close because everything you have in there has now been synced to the cloud, so I could retrieve it. This is the number one reason why students have missing and incomplete homework assignments, is because they put something in there and then closed OneNote real fast and didn't have a chance to let the syncing happen. Okay, and you notice now that that little green circle is gone. Alternatively, if you're like super type A, if you right click this, you could also do notebook sync status, and it lets you sync all of your shared notebooks all at once, and it gives you like a little status bar that shows you when the sync is actually all the way finished. You could do it this way as well. It's doing the same thing. Is everybody okay with that idea? Yes, sir.
So will this be our like notebook? So do we need a physical notebook?
If you want to take all your notes in OneNote, you can do that. If you want to use a physical notebook, you can do that. Where we're going to turn the homework assignments in is going to be in OneNote. You don't have to write your assignments in OneNote. You can write them on paper, take a picture, and drop that image into OneNote. Let's practice doing that right now. Okay? Since probably a lot of us would want to do our homework that way and probably have never done this before. So take out your cell phone. Take a picture of something. Doesn't matter what it is. This would potentially be you taking a picture of your homework assignment.
No. So no. I'm looking at the my screen.
Okay, so open up your cell phone, take a picture of something. It doesn't matter. And then we're going to email that picture to yourself, email it to your Notre Dame email account.
Right, it's too high tech.
Almost airdropped it. Sarah.
So once you've emailed it to yourself, open the email. At the bottom, you'll see the attachment, right? Click the download arrow. This is on your tablet, not on your cell phone, by the way, folks, right? And then you'll want to save that somewhere where it'll be easy to find the icon. My suggestion would be to save it to the desktop. Okay, so go ahead and hit save. Your camera on the tablet is not high enough quality.
No, I mean like you email it to yourself and then pull the pictures and screenshot it.
I don't know if it's going to be readable.
Okay.
Like it's not the same data as getting like I don't know is my answer. Maybe.
I'll try it out. And if it's
Yeah.
not cool, then I'll do it.
Yeah.
Can you repeat what you did like once I had the picture in my email?
So you opened your email and you have like an attachment at the bottom. You're going to click the down arrow to download it. And then you're going to pick some place to download that it's easy to find the icon. I always just use the desktop because it's super easy to find that because it's like all I got to do is look on the desktop. It's staring me in the face. So hit save. And then once we've done that, we just make a tab or make a new page, right? So I'm in current homework. I hit add page. And then I just take my icon, I drag it into the white space, and I let go and pick insert printout. And the computer will dump that image in there for you. Oops. See, there it is. Now I'm going to delete this out of here because I was doing it in Alexis's. It work? It's sideways. So, yeah, if you right click, there's a rotate option and you can rotate it so it's facing the right way. Yeah, no problem. Well, if she's looking at her name section, you're looking at your name section, they are going to be different.
Than everyone's.
Okay. If I right click, it's just not working.
I don't know. It's like updated on this.
No, you just have the expanded thing going on. You just need to.
Forgot what she used. A different color purple too.
Oh, you're using the Windows version rather than the. You want the app, not the Windows version. And 7th hour trig. So we'll do that. Do you need your chemistry notebook in there too?
That would be good.
So, see what I'm doing? Is I'm just doing open other notebooks. And if you look at this queue of recent things,
Okay.
there you go. And now they're in this one. And this is the version of OneNote that I think is
Okay.
much more user friendly.
The other one's very high tech. A little confusing.
This is more user friendly, I
Okay.
think. But everything is there now.
Cool.
So like, there's your name, content library, etc.
Okay. Thank you.
You're welcome.
Put it in archive.
Current is where the stuff to be graded goes.
What is the difference?
Did you guys get your pictures in? So that was just practice. I don't actually need these pictures for any reason. Feel free to delete it once you've done it. It's just to let you practice doing this. You don't need to leave some weird, embarrassing picture of your neighbor or the picture of up your nose or whatever you took. The stylus is helpful. Now, again, for the sign-in sheet, you could print it and just do it physically. Take the picture and dump it in. Whatever works for you, I am okay with. Not going to be picky. As long as I can read what you've done, I'm happy. This just allows me to not have to handle stacks of papers. And there's no waiting for me to pass something back. It's like you still have the copy of whatever work you did. If it takes me a minute to get it done or whatever. All right. So that's your OneNote introduction. Okay, we'll continue. We'll use OneNote every day. Or I'll use OneNote every day. You might not use it every day. But if you have problems or you don't know how to do something or you're not sure what's the easiest way to do this or that or whatever, let me know. I would be happy to explain to you the best or the way that I would do this. I don't know if it's always the best way, or if I know how to do it, if what you're looking to do. I'm happy to try to help, okay? All right. That's OneNote. Next up, if we go back to or if you keep on your tablets, go to our bulletin board. What we're going to do now is under the links section, we're going to click that deltamath registration link. And then you would just do register with Google. Pick your Notre Dame account, and then I think we're done. I think that's all we need to do for today. You're not going to do anything in deltamath today. We're just going to register for it so that you guys are in my class. Very easy, right? Look at the teacher code is already in there for you. That's how clever Mr. Kulik is to set this up. So it's it's as simple as you can possibly get, right? Yes. Okay, has everybody gone and done the registration? Should have been just a couple of clicks. No. Okay, again, you clicked deltamath / registration. Register with Google. Pick your Notre Dame email account. And then confirm, and I think you're done. Okay? The only time you're going to use that registration link was today. From now on, if we're doing anything in deltamath, use the deltamath link. I'd probably bookmark it because it's something we'll use probably weekly at least, but it's fine. You can always come back here and use it, but it'll get buried as I add more links in. Okay. Do we have anything else? No. Okay, good. So that's the setup so far. We've done everything setup-wise we need to do today on the computer. So we're going to start actually talking about some math stuff now. Right? I'm excited too. So what I'm doing right now is I am in OneNote in the content library. I am the only one that can edit things in the content library. You can see them, anything that's in the content library. You can take the pages from the content library and copy them into your notebook and edit them. But if you're in the content library, you can't change anything that's in there. Only I can do that. This is where I'm going to write the notes for the class because I'm writing the notes in the content library. What does that mean for you? You have them all automatically, right? Anything I write in here is going to be viewable to you. So what does that mean? What does that mean if you have all the notes? It means you can follow along in the way that you see fit, right? If you want to take pencil and paper notes, you want to write things down, and that's how you like to do things, I encourage you to do so. I was not a student that could pay attention if I wasn't like actively doing something. So even though I might never look at them, I wrote down notes every single time because it helped me pay attention. If you are I'd rather just sit and listen because things go too fast and I get worried about writing things down and I'm not listening to what I'm hearing. I'm just recording information on a piece of paper. And when I get done with class, I didn't hear a single thing or understand anything that happened. And you're like, I'm just going to sit and watch because I already have a copy of the notes. That's fine too. If you want to experiment to see what works best with you, that's okay. Everybody's cool? Very nice though, right? If you miss class, do you need notes from somebody? No, you have my notes. So that's pretty nice. Okay? All right. So let's begin. This course is trigonometry. If I look at the root word, what does that look like to you? Triangle. And then if we have like ometry at the end, like geometry ended with that same thing. What do you think ometry means? Just like study of, right? So what is trigonometry? Like the study of triangles. It's kind of what the root word would imply. Where did we last encounter triangles on a regular basis in math class? Geometry. So that is kind of our foundational starting point for this course. Now, we're not going to live in geometry land for long, but that is kind of the starting point as we're picking up where we had left off from geometry. Now, that was a year ago, right? You had a whole other class in between. So let's do a little refresher. Okay. So what do we remember about triangles from geometry? Anything that you guys might remember? Could be names, can be theorems, could be facts. Okay, so let's call that, I'm going to write it this way, SOHCAHTOA, okay, right? What does that mean again? Okay, so sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. But there's a little bit more to it than that. What piece is still there? Does that work all the time? It doesn't. What do we have to have in order for this SOHCAHTOA to be true? What kind of triangle do we have to have? In a right triangle, yes. Has to be a right triangle. And because it's a right triangle, we know that it's going to have two acute angles. The name I'm going to give one of those acute angles is going to be theta. So that circle with a line through it is the Greek letter theta. The convention in trigonometry is when we use a variable to represent an angle, we use the Greek letters. When we use a variable to represent a length, we're going to use like the normal alphabet letters. That's just the convention, or a convention. Okay, so make an observation here. Sine, cosine, tangent are like operations, right? They're mathematical operations. What type of quantity can you take the sine, cosine, or tangent of? Have to be acute angles, right? So numbers between 0 and 90 degrees are based on our definition that we have here, are the only things we can take sine, cosine, and tangent of, right? And the opposite, hypotenuse, adjacent, what are those quantities? Those are lengths of sides in a triangle, in a right triangle. Okay? So let's say that we have a right triangle here. And I'll label the vertices A, B, and C. When we draw a picture of a triangle and label the vertices, we usually use capital letters. That's the convention. And based on the labels we've given the vertices, we're going to label the side lengths similarly, right? So the side that's opposite angle A, we're going to name with a lowercase letter a. The side that's opposite vertex B, we're going to name with a lowercase b. And the side that's opposite vertex C, we're going to name with a lowercase letter c. Everybody's okay with that? So, if I am taking, say, sine of angle B, which of these sides is the opposite and which is the hypotenuse? Okay, opposite is which letter? Lowercase b. Since I know lowercase b is opposite angle B. And the hypotenuse is C, always the longest side, right? How do I know C is the longest side? Because it's opposite the largest angle, right? So that was another fact we would have had from geometry. The side lengths of a triangle are proportional to the opposite, well, let's say, I shouldn't say side, I should say the angle measures. No, that's right. Side lengths. Yeah, I don't want to say it that way. Of a triangle are proportional to the opposite angle measure. So again, what that means is the longest side is opposite the biggest angle. The middle side is opposite the middle angle. The shortest side is opposite the shortest or smallest angle, right? Now, keep in mind, if I look at, sorry, we took a little aside there. If I did sine of angle A, what's opposite now? What is the opposite if we're doing sine of angle A? Side A, right? So when we say opposite, adjacent, hypotenuse, it's always relative to the angle that we're looking at. Does everybody see that? Again, these are things that you would have done in geometry, but that was a long time ago, so we're going to just kind of walk through these important ideas here carefully. Is that so far okay? Stop me if you're confused, or ask me a follow-up to clarify if you're like, I think I got it, but what about this? Any of that stuff's okay. I don't live inside your head, so it's hard to tell how we're doing. So that was a big piece of triangles related to geometry, was the SOHCAHTOA piece, and that turns out to be kind of the starting place for where we're going to go in trigonometry, but there's a lot of other triangle things that we would have talked about that probably are also worth reviewing. So I'm going to pause on SOHCAHTOA and talking about how that's going to lead into geometry, and continue talking about some triangle stuff and circle back to it then after in a few more minutes. Does anybody else remember some triangle things from geometry? We have 2 things on our list. There was a lot more. It seemed like half of geometry was triangle stuff. How about triangle names? Does anybody remember names? The ways we name triangles? Like, great. So there's 2 ways to name triangles. One is based on the sides. So equilateral was one. What's an equilateral triangle? All the sides are the same. What's isosceles? 2 are the same. And what's the third type where no sides are the same? Scalene. Good. The other way was based on angle measure. What are the 3 names for triangles based on their angle measures? One of them we've said already, which is the right triangle. What's that mean? If a triangle is a right triangle, what does that mean? It's got one 90-degree angle in it, right? Exactly one 90-degree angle. What are the other 2? Obtuse and acute. Good. Acute is it has all the angles are less than 90 degrees. And obtuse is all the angles are, or I'm sorry, it has one angle that's greater than 90 degrees. Excuse me. It can only have one angle greater than 90 degrees. Why is that? Why couldn't it have 2 angles that are bigger than 90 degrees? Why? You're right. Because, there you go. So they were talking about the triangle sum theorem, which says that the sum of the interior angles of a triangle is equal to 180 degrees. So if I add up all the angles inside a triangle, they have to equal exactly 180 degrees. If you had 2 that were bigger than 90 degrees, that's impossible, right? Too big, too many degrees inside that triangle. Can't be a triangle anymore. Everybody's cool? Remember that? That was one you probably used a lot. Might not have remembered the name, but that's okay. The name's not important. Just that there's 180 degrees in a triangle would be a good one to remember. What else? Oh, good. So we have special right triangles. Yeah, very good. So one of them is the 30, 60, 90 triangle. So in a 30, 60, 90 triangle, the ratio of side lengths are x, x root 3, and 2x. And again, it should be easy to remember that because the coefficients on each of the variable are 1, square root 3, and 2. If you put those in order, 1 is 1, square root of 3 is like 1.69 maybe, and 2 is bigger than that. So we know that, like, okay, shortest one is 1. That goes across from the 30. Medium one is the square root 3. That goes across from the 60. 2 is the biggest. That goes across from the 90. The other special right triangle is the 45, 45, 90. if we were to name the kind of triangle that the 45, 45, 90 is, using the sides and the angles, we'd call that an isosceles right triangle, since two of the side lengths are the same, and it's a right triangle, so it's an isosceles right triangle. Just to connect the vocab we talked about a moment ago to something here. So again, the side lengths in a 45, 45, 90 triangle are x, x, and then x root 2. Again, the coefficients are those on those sides are 1, 1, and the square root of 2. The square root of 2 is about 1.41. Bigger than 1, so that needs to be the hypotenuse. Okay. Cool. We had the special right triangles. Good remembering on those. Again, these will be handy for us. We do a lot with these in trigonometry. What else do we remember from geometry? There's a couple more that I'm looking for that are kind of important. Okay, sure, the Pythagorean theorem. What does that say? Okay, a little bit more to it than that, because is a squared plus b squared always equal to c squared? So to be able to apply the Pythagorean theorem, we'd say in a right triangle, the sum of the legs squared equals the hypotenuse squared. So the takeaway here, the thing we have to be careful about, well, two things really. One is that the side lengths are coming from a right triangle, and two, that we're plugging in the value of the hypotenuse for the c, right? One of the most common mistakes I see students make is putting the c in the wrong place, like plugging in the hypotenuse for a or b or something. Does it matter which number goes in for a, if between the legs? No, right? The one that you have to worry about is the hypotenuse must be the c. One of the legs could be a and the other could be a, b, b. It doesn't matter which leg goes where. Everybody kind of remember that? Good. Pythagorean theorem, that's an important one. What else? Okay, the one last thing that I'm looking for applied to things more than just triangles, could apply to any geometric figure. There's a whole bunch of theorems about this. So we had congruence and similarity. So congruence was the equal sign with the squiggly on top. And similarity was just the squiggly. Okay. Congruence, if two figures are congruent, what does that mean? Okay. More than that. It basically means the two figures are identical. All the side lengths have to be the same. All the angle measures have to be the same. They are, other than the names of the vertices, identical. Maybe we'll just say. Okay. What does it mean if the two figures are similar? It means that they're the same shape, but not necessarily the same size. So we're saying that all the angle measures are the same. And the side lengths are proportional. What does proportional mean? So say we have a triangle with side lengths 3, 4, and 5. And we have another triangle with side lengths 6, 8, and 10. Those side lengths are proportional because 2 times 3 was 6, 2 times 4 is 8, 2 times 5 is 10. Is that there a scale factor involved? It's like a dilation. Remember dilations? Two figures created by a dilation are similar figures. So it's just like an expansion or contraction. All right. So there were some theorems involved with proving things were similar or proportional. Does anybody remember any of those theorems? There's a whole mess of them. They all had 3 letters, or most of them had 3 letters. Somebody give me a guess at one?
Was there one like side angle side?
Great. Side angle side is a congruence and similarity theorem. Good. What else? There's side, side, side. That works for both of them. There's angle, side, angle for congruence, but really just 2 angles is enough for similarity. You don't need the side also. It's fine to show that you have a pair of sides that are proportional, but you don't need it. There's angle, angle, side, which again, 2 angles is enough for similarity. Is there any others? Yes, sir. You sure?
Yeah.
Okay. There's one more, congruence one. It has a special name. It's called the hypotenuse leg theorem. And this is a special case of side-side angle. Side-side angle is not a congruence or similarity theorem. It only works for congruence in one very special case, and that's when the angle involved is a right angle. So, okay. Here's the $100 question. How is similarity related to SOHCAHTOA? That's okay. This is the topic that even if you're like the honors geometry, it's a topic that doesn't sink in very well. Here's the deal. Let's just do an example to kind of illustrate, okay? let's say we have two triangles. One is a 3, 4, 5 right triangle. The other is a 6, 8, 10 right triangle. Who's okay with that? I'm going to name this one, I don't know, A, B, C. And this one will be D, E, F. We can say that triangle ABC is similar to triangle DEF because, well, 3 over 6 is equal to 4 over 8, which is equal to 5 over 10, which is showing that all the side lengths are proportional, right? That's side, side, side that we just did there. Is everybody okay with that? So it's showing that the ratio of corresponding sides is the same for both triangles, for all sides, all pairs of sides. Okay, so if I do that and I look at sine of angle A, that's going to be opposite over hypotenuse. And then I look at sine of angle D, that's going to be opposite over hypotenuse. What do you notice about the fraction 6 over 10? It reduces down to 3/5. That the sine of angle A and the sine of angle D are exactly the same, right? So why sine, cosine, tangent work? What we've done is we've noticed that if I have a right triangle with a known angle, any triangle that's similar to that is going to have identical ratios of side lengths. Right? Just like what happened here. We had two triangles that were different sized, but they were similar, and the ratio of the corresponding side lengths was exactly the same. That's why the value of sine of an angle is going to be the same regardless of how big the triangle is, because all the triangles with that right angle and that given angle are similar, so the ratios of side lengths are all the same. So what sine, cosine, and tangent are doing is they're taking every possible angle measure, acute angle measure, so from 0 to 90, and mapping that to a specific ratio of side lengths. Okay? This is the foundation of the trigonometry you studied in geometry. It was all built inside of these right triangles. So the only things you could take sine, cosine, and tangent of were angles between 0 and 90 degrees. Right? Now in the real world, are there angles that are bigger or smaller than that? Certainly bigger, right? What's the biggest angle you could possibly have in the real world? I think it'd be bigger than 180, right? If you measure an angle this way, that could be bigger than 180, right? I think if you, well, what if you have, okay, so let's say we got cars, right? Everybody has been in a car before. How does a car work? So the engine, right, creates some kinetic or takes some chemical energy, converts it to kinetic energy, and the drive shaft spins, right? And that motion is transferred to the wheels, and that's how the car goes. A really simplified version of that. But how many degrees is that drive shaft going to turn in, say, 10 seconds? Could be way more than 360. How many times is it going to spin around? It's going to do lots of revolutions in 10 seconds. That drive shaft's going really fast. You could have like millions of degrees turned in 10 seconds. right? So anything that's spinning could certainly go through an angle that's bigger than 360. Does that make sense? And from an engineering standpoint, how many machines have spinning parts in them? A whole bunch of them, right? That's not an uncommon feature at all to have spinning parts. Is everybody okay with that? So certainly we should care about angles bigger than 90 degrees because there's lots of stuff that would involve angles bigger than 90 degrees. What about smaller than 0? Can we have angles that are smaller than 0?
No.
Well, if we have the drive shaft turns this way, and that's positive, what would a negative angle maybe be? Spinning the other way, right? We should have some way to differentiate the two. We could refer to that as a negative angle. So clearly negative angles of any size would be potentially quite important to us also. That's going to be the foundation of, I'm just checking the time, the foundation of what we're looking to do in this first half of first semester. Is we're going to take these definitions we have for sine, cosine, and tangent that are stuck inside of these right triangles and generalize that definition for sine, cosine, and tangent so that we can apply it on an angle of any size. That's going to be the goal. Now, it's going to take probably half a first semester to do that and to really kind of build that all the way out. But that's the first half of this semester. And then using those new definitions, we'll kind of explore what we can do with that in kind of the second half of first semester. Okay? So, to be ready to do that, where'd my thing go? Cursor, what's going on here? Ugh, stylus problem. So to do that, let's do a little review here of doing some of this right triangle trigonometry stuff that we would have done in our geometry class. So let's say we want to solve for x here. This looks very much like a geometry problem you would have seen 2 years or a year ago or whatever, year and a half ago. This would have been a second semester geometry topic, so let's say year and a half. Does anybody remember what to do with this? The correct answer is I can't do anything with this the way you've currently written. What's wrong with this? Why can't I do anything with it right now, Mr. Kulik? Got a guess? Go ahead.
You don't have, it doesn't give enough information.
What information what information would I need?
Side length.
Side length still isn't going to help me solve this. I need a right angle to be able to do anything with this, right? Even if I had another side length, I still can't do the Pythagorean theorem because it's not a right triangle. Now, it looks like I drew a right triangle, but do I know it's right? No. Why not? Doesn't have the silly little box in there. So let's add that box in. Now you should be able to do this even without another side length. What's the key here? That I've been given the angle. Relative to that angle, what is 17? Opposite, adjacent, or hypotenuse? Opposite. What is the x? That's hypotenuse. So which trig function can I use? Sine. So I can say sine of 36 is equal to opposite over hypotenuse. Everybody's okay with that? Geometry is now done. This is now an algebra problem because we're just solving an equation now. To solve this equation, what would be my first step? Well, x is in the denominator. So if I divide by x, I'd have 17 over x squared. Instead of dividing, you should multiply both sides by x. Yup. Okay. So that gives me x times 36 equals 17. Then what? What's that? It's not divide by 36. I'd divide by sine 36. Remember, sine 36 is just a number. It's just a ratio of side lengths. It is all one thing. Okay. So that'll do it for us. So I'm going to fire up my calculator to do this. What do I need to be careful about when doing this on my calculator? If I'm using sine, cosine, and tangent, what do I have to be really careful about? The mode of my calculator. What mode should my calculator be in to do sine, cosine, or tangent? Needs to be in degree mode because I'm doing sine, cosine, or tangent on 36 degrees. To change the mode of your calculator, you press the mode button right next to the blue second. And then right now my calculator is set in radian mode. So I'd want to change that to degree. If you're working with angles that are in degrees, your calculator should be in degree mode. If you're doing stuff with radians, your calculator should be in radian mode. So it just depends on the problem. Right now, with what we've done, it should be in degree mode. We haven't talked about what a radian is yet. Okay. All right. So then I'm going to do 17 divided by sine 36. The way I like to do this is I'm going to write it like a fraction, just like it looks like on my sheet of paper. To get a fraction on your calculator, you can press alpha, that's the green button, and y equals. This opens up the fraction options. I'm just going to pick the first one. So now I'd have a fraction on my calculator. So I can do 17 on top and sine 36 on the bottom and press enter. So there's my answer. If I wanted to round that to the 100th, what would I write as my answer? 28.92. Okay. Okay. We'll pick up kind of from here next time. We'll do a little bit more review on this, and then that's going to be your first Delta Math assignment, is going to be doing some of these kind of review problems from geometry. We'll do a little bit more together in class, but that's going to be our first stepping off point, is reviewing some of these right triangle trig things from geometry.
Is it so for the delta?